Hello once again. A friend of mine gave me this ASUS laptop to look at, and I already know what the issue is because he sent me some pictures, and I will put them up so you guys can see. He accidentally broke the battery connector on the battery itself and on the board. He thought it was like totally done for, so he asked me if I could potentially look at it, and so now it's here on the bench. I guess he had reinstalled Windows on it, and for some reason, after doing that, he said it wouldn't charge anymore. I don't know why that would have been. Maybe coincidentally, maybe something happened with the power adapter, which we have here as well. So we're going to check that. I said, maybe the connector on board where the power goes in could be, bad. Not entirely sure, no idea. But I mean, even if we were to take care of that, we still have the issue with the battery. So let's see what we can do about it. I haven't seen it in person for myself yet, so we're going to open it up and take a close look in there. I think it might be repairable from, the pics he showed me here that you saw as well. And there's another picture he showed me where it's like the whole thing's just in pieces. So, like I said, it's just connectors, so I think we could probably do something about it. So let's take a deeper look inside here. After removing the screws, the back of the case comes off relatively easily. I've just got to snap it around the edges. I've never taken one of these apart, but it hasn't been difficult yet. So here's the battery connector. As you can see, going straight into the pack right here. And there is the spot on the board. We're missing two traces, like right in the middle, two little thin traces, and then the positive and negative, as we can see here on this connector. And then the two center ones are probably for communicating with the battery pack, like board to battery pack. Okay, so here's a closer shot of those pads there. Looks like we're missing a little more than I actually initially thought. So we're missing a little bit here, but that's not a big deal. I mean, this whole thing's a trace here. We can do something about that. And then we're missing those two, as I mentioned. We have a piece here where this trace that goes here to this resistor, so we could tap into that. That's not a big deal. And we have a via right here that we could actually just scrape some of the material off of that. I mean, it didn't like pull the via up, so we should be able to just tap into that if we can, scrape away the resist off the solder mask off of that. And looks like we're missing part of a trace here. It's just a pad there, so that's not a big deal either. The little mounts for the connectors are still left on the board here. So there's the one there, and then there's the other one here, so those didn't come off. On the battery connector itself, you can see where the plastic is broken off on the end there. So we have our two of the negative connections exposed there. I mean, we can't really use this. We have no connector on board to connect to. So I think we're going to have to just replace both of these with something else. I happen to have this protection circuit here from a battery pack and the power supply that it plugs into from this one of those big Navi tablets that I had taken apart. And it has six conductors for the positive and negative on the battery, and it's got the two for communications as well. So I think we might be able to take this and adapt it to work on here. The wire gauge on this is a little bit thinner, although I guess we'll see exactly how much thinner it is. If it's not too bad, I don't think it should be a problem. The spacing on the pins here, the pitch is a little bit finer on this one as well, but not a deal breaker because it's pretty close. So I think this should work. Since we're obviously going to have to mess with the battery here, I lifted up this covering tape that it's got along here, and that exposes the protection board there, and it looks like we should just be able to tilt this out, hopefully. Actually, if I'm gentle enough, this is actually not really giving me much resistance, and that should give me enough room to get in there with a soldering iron and just remove everything. If we orient these connectors here in the way that they would both be, we can see that the positive and the negative are on the right sides, but that yellow and the white wire in the center will have to be swapped. And not that they have to be swapped, but I would just want to keep some consistency. Alright, so while trying to be careful not to melt, break, or short anything, this is out now. There is a little bit of difference in the gauge of the wire, but I don't think it should really be a big deal. Although if it does end up working, then I'll just monitor it for a while and make sure that the contacts aren't getting hot or anything. But it's I mean, the original is so short that it's probably not going to be a big deal anyway. It's not like we're going to have like a lot of resistance or anything between the battery pack and the main board. I decided to check the voltages at the positive and negative terminals here on the end, and it's showing nothing on the multimeter, but there is a few voltages present here. I don't know of the arrangement of the cells inside of this thing, so I wouldn't be able to know which one's supposed to be what. But I mean, they are showing something, so I'm guessing the batteries aren't totally bad. Hopefully that's not the actual issue with this whole thing, and the whole reason why I wasn't charging is that the battery was bad. But I'm hoping that maybe once we plug this back into the board and hook up power to it, that it charges them up a bit enough and it resets the circuitry. Because as I had shown before, on like a lot of batteries like this, the protection circuitry will turn off the output, until it gets reset by something else to, allow it to work. That way the batteries don't get over discharged or anything. So yeah, we'll see about that. Okay, now that we've got the battery mostly taken care of, except for I haven't put the new connector on yet. Let's take this stuff off here because it's pretty useless to us. We can see right there on the one in the middle here where, yeah, the pad got torn up, or did it? Wait a minute, maybe not. Huh, well that tinned, so maybe it didn't get damaged after all. How about this here? This one does look like it's torn for sure. Removing a surface mount connector like this one isn't exactly the easiest thing. While we could use like some chip quick or something and like do the usual where we heat everything up and put some of that chip quick on there and try to move it off as fast as we can, heating it up with the solder still sometimes melts the connector. And I don't really want to do that, but luckily this one here is at the edge of this board, and this board is thin enough that I believe if we just hit it from the bottom here with the hot air gun, or it's actually the rework station, the hot air rework station. If I hit it from the bottom here, once the solder starts to flow, I can quickly just move it off the board here with minimal damage. So that way I can salvage this, because it's not like I have another one of these laying around anywhere. So I'm going to have to try to take this off in one piece. So I'm going to turn this on, and I'll begin heating it from the bottom here. And I'll just kind of gently tap it, and hopefully once it gets hot enough, it'll release. I'm trying not to get any of that. It looks like I've got the hot air, kind of going above here, but I really don't. This is actually below the level of the board, so I'm just heating the board from below. It's going to take a few seconds here. It's not going to be instant. And also, if I was like trying to hit this connector with the hot air from above, I'll probably melt the plastic before the solder even starts to flow. So that's what I'm trying to avoid. There we go. It's releasing now. Come on, come on, come on. This side. I got one side done. Come on. There you go. Okay. There's the connector. As we can see, not molten. No damage. All in one piece. Alright, let's see how this fits here, or how well it aligns with everything else. Let's see, we got our 3 out there, and it's a little close, but if we align the ones in the middle there, I think everything else we can make do. What I'll have to do is I'll have to scrape off some of the solder mask off of here, and then just bridge all that together right there. And there's this funky, I don't know why this would be, but it looks like it's got some impedance match sort of stuff going here. They've got like that one trace, it's all squiggly. So I don't know, might have to do that as well, but I think that should do it. The tabs here land exactly where the original tabs were. So I might just scrape off a little bit more here just to give it a little bit more area to solder to, and on the other side as well, like right Well, it's a little off, just a tiny bit, but it should do the trick. Now this via here, without a schematic or anything for this board, good luck trying to find where it goes, right? I mean, it'd be so much easier if, you know, we could just tap directly into wherever it is that it goes and then just run a wire from there to where we need it out here. But like I said, luckily, looks like this is mostly still there. So I should be able to just tin this and then add a wire as a lead here, or a trace, to, you know, try to get it here where we need it. Yeah, there's plenty of material there to solder to. I'm just gonna have to be careful to not accidentally yank the new one out. Alright, let's try to tin this via here with this really tiny tip. I got this solder on the tip of the iron instead. I mean, it's gonna be pretty difficult because the via is tiny. This little tip is tiny. It's gonna be hard to try to heat up the via and get the solder there to touch the pad itself, or touch the copper itself. So basically what I'm hoping for here is that I can heat up the pad enough and get the solder to flow. Oh, it's working, it's working. It's gone. Yeah! Sweet. Ay, so tiny. It's like really tight space here. Let's tin this a little bit too. See, that one was a lot easier. That looks huge, but it's not that much. I've got this little piece of wire here. There's a bit of a bump on the end there. I just gave it a tiny loop so that I could get a little bit more solder than I would have been able to otherwise if it was just you know, like one strand of wire there. So I'm going to try to melt the top of that and get it to adhere to that via there. And I'm doing this through the LCD on the camcorder, so I'm not even looking at this directly. I cannot get this to go. Come on, come on. Stuck. It feels like it's stuck, but I'm not too thrilled there with how it's close to that resistor. So I'm going to try to get it aligned. Oh, it looks like I got more solder on the via though, so that's good. Let's get these two to melt together. There we go. Cool. I'm going to try to shape this a bit here. I'm going to try to push it down. Okay, I didn't like that. I felt like it popped out. I want the wire to sit as flat as possible on the board. Okay, that feels like it did something. Nope, it's not very solid. You can see that it wiggles. Nope, it's loose. Is it? Yeah, it's loose. Okay, but there's still solder there on the via, so that's good. I'm just really worried about, you know, tearing it out. No, it's at an angle. I'm not. Hey, try to hold it down here so I don't pull it out, and I'm going to try to shape it around. It came out. Ah, no. Okay, looks like there's still material there. Nope, it's moving. Okay, pretty sure that's stuck again. Now let's shape this here. So I want to try to get it just as far as that pad there, and then I'm going to snip it. But at the same time that I'm trying to get it down here, I cannot move the spot where that joint is up there. So that almost. I've got a little bit of flexing up here. Okay, now right there. Whew. That was terrible. Okay. Oh man. Alright, so that one's hard, but this one here should be a breeze. There, it's already stuck. And I guess I'll run it along where this trace is missing here, just to avoid any potential issues, and if, you know, for whatever reason this was done. This is moving. I think I'm going to have to just solder it directly to that resistor there. Okay. See, this is no problem because this one's not as fragile as that other one. Okay, I don't want to touch that other one. I keep bumping that other one. I don't want to damage it. Oh, man, this is scary. That looks terrible. Alright, I'm going to snip it right there. That should be enough. So there's our two new traces there. I'm not going to say it's my best work, but it should work. Those two right here look like they're a little close together, so let's see if I can get this to separate a bit. I'm going to pull this down. Just don't want it to be too close. Okay, that should do it. Right here, I'm not exactly liking how that one's looking there, but I think we might have to live with it. I give this area a bit of a cleaning with some alcohol and a fine bristle toothbrush, just to try to get a little cleaned up. As if this works out, then I'm going to probably put a dab of like CA or super glue here just to kind of hold this down, because I don't want any of this to be vibrating and potentially break off. It seems like it's pretty solid as is. I don't want to mess with it too much, but I'm going to now put the connector down here on the bottom, and like I said, I'm going to have to scrape some of this away here in between these pads, just so I have more surface area to solder to. Okay, so I've scraped away some of the copper there in between the pads for the main battery terminals. I'm going to tin them first, and as you can see, we do have a hole there, so it's it did rip out that pad. Okay, so now that those are tinned, I'm going to remove the excess solder, just to try to make it as flat as possible before I put the new connector on. Alright, so now those two mounting pads here, scraped and tinned. You know, ideally it would be good to have replaced this with an identical connector as the one that was originally on here, but I don't have anything like that, and I'd have to, you know, try to figure out what that connector even is. So for the time being, we can just do with this, and then if later in the future, you know, they decide got to replace that battery, you can try to hunt down the actual connector that's supposed to be here, and then just replace this one. And because it's not like we're permanently modifying anything on here, we're just kind of adapting it to work for now, and to make sure that there's not something else wrong with it. You can do it, come on. It's not sufficiently tacked down yet, but it should be enough to hold it for me to do the other side, and then I'll come and hit this one again. Looks like our alignment up there is mostly okay. So let's do this side here real quick. I was trying to rely on just the solder that's left on the pads here on these mounting tabs, but it might not be enough, so I'm going to add a little bit on this side to get it to flow on there. There we go, much better. So now I can go back to this side. Oh, this one's being a little tough here, but come on. Okay, that should be okay. It should be tacked onto the bottom there, so that should hold. Alright, let's hit these. It's probably not the best tip to be using for this. It's kind of big, so I'm going to switch it out to something smaller. I want to get all this to bridge together, and it looks like that should have done it right there. That looks okay, I think. Now let's get these here, and this is really impossible behind the camera. I'm going to try to get here at an angle. Okay, now let's try to do this without breaking anything any further. Yeah! That's good, I think. Okay, yeah. Woo. Okay, so that's where we're at. I ended up having to hit the left side connectors here, or the pins, a little bit more because the one right here, the third one in, didn't look like it had flowed very well. So I just hit it again, and now it looks like it should be fine. So let's do the battery side now, and then after that we might be able to test it. Putting the new connector on the battery, I didn't think it was going to be all that exciting, so there it is. Before we go too much further, let's see if this power supply is even working. So I've got it plugged in, and I'm going to stick a wire here in the center because it's not like I have a probe thin enough to go in there. And outside should be ground, and this should be positive, and it's what? I don't think the power supply is working, Josh. That's no good. Well, that's interesting. Checked here just to see if there was a short, but it's kind of hard to just get it on the pin there, but it doesn't appear to be any shorts, so I doubt that would be the reason for the power supply having died or whatever. Oh boy. Okay, I kind of doubt it, but let's just rule this out. Let's see if this needs to be plugged in for whatever reason before it starts doing anything. Like I said, I really doubt it, but I don't know, I've seen some strange things before, so plug it in. And now let's see if we're getting anything here at the... See, this would be ground, and this should be fine. And that would be positive, and... yeah, that's like something discharging there. It doesn't seem like it's doing anything. Well, that's no good. Alright, well, we're going to try something here. I have this little HP power supply that's also 19 volts, except it's a lower amperage one. This one here is only 1.58, where this one's up to 2.37. But it should be enough to allow us to test, just to see if anything's going on here. The barrel connector it has is pretty much the same size. I just don't know if the contact in the middle there's actually going to contact the one on the barrel connector on the board. But let's give it a shot. It shouldn't harm anything. First of all, let's make sure that we're even, just to verify that this one is working for sure. So yeah, 19.142. So this is working. I don't know if we're gonna be able to, I don't know if there's any LEDs on here for like charging indication on this thing. I guess the best way to test it would be to just plug it in and see if it even powers up. We'll leave the battery disconnected for now. But let's see. Hopefully nothing dramatic happens when I plug it in. Nothing, okay. Alright, alright. Don't see anything happening. Okay, let's see if we're even getting power at the input there. So we should be seeing 19 volts right here. Yeah, okay. So that's making good contact. So what is the deal? Oh, there we go. We do have an LED. Oh. Whoa, that could have been disastrous. But anyways, the LED here on the side did light up. Oh, there we go. I got something. Okay, yeah, it's the barrel connector's not making very good contact. So if I kind of bent it a bit and I got some, there we go. See, there we go. See, we have some LEDs here on the side and it's off again. There it is. Okay, so as long as we can get power to it, I think we'll be able to do something, but I'm gonna have to try to figure out a way to get this thing to work in there. The barrel connector has two little kind of like spring terminals inside. They're kind of like this. So I tightened them up on the HP connector so they're a little bit closer together, and now when I plug it in, we are getting consistent contact. So as you can see, we are getting power to this. So now, let's see if we're getting anything here at the battery terminals. 12.282. Okay, so it is attempting to put something to the battery. So I think now we should be able to put the battery in and get it to work. The battery is 11.55, so it does look like it's trying to charge it. Alright, let's give this a shot now. Alright, I put one screw here just to hold it down for now. So this will just connect into our new connector here. That. Man, custom. Let's plug the HP adapter back in, the power, and let's see what this LED here does now. Saw a flash there, and it's orange. So it looks like it should be charging, and it powered up. Is it doing something here? Yeah, it's booting. I don't want to flip it over too much, but there is stuff on the screen, so it is working. And you can see hard drive activity right there. It came up, and I'm trying to not move it too much because I don't want to lose contact in that barrel connector there. But we do have an icon here with the battery and the little plug symbol. So I'm just going to turn it off, and I'm going to let it sit for a while, and hoping that it charges up. If it charges up, then we know everything's good. And I'll also keep track of that connector there, make sure that it's not getting too warm or anything. Been sitting here for about 10-15 minutes now, give or take. And the battery's at 11.9, so it looks like we're doing pretty good so far, but it's not fully charged, obviously. At the connector here, it does feel a little warm, but I'm not entirely sure if that's due to the actual, contact resistance between the board and the connector going to the battery, or if it's due to this inductor right here, because this inductor is pretty warm, so it could be that that's just warming up this whole entire area of the board, and it's causing this to feel a bit warm. Because yeah, actually this screw right here, that does feel quite warm, and that's that's all copper right there. So I think maybe the heat that we feel on here is just this whole area being warmed up by the electronics around it. Took about 2 hours, or actually it was a little under 2 hours, but the LED finally turned green. So hopefully that means that it fully charged and it should be working okay. And the icon in the corner is showing full charge, so looks like we got good contact on that one via that was completely obliterated, because it appears that the main board is communicating with the battery. Okay, so now we got to deal with the charger. There are no signs of damage to the cord at all on this power supply. There's the one coming out of the box here, and really nothing obvious here either. But as we saw, we were getting absolutely nothing from that. I'm really not a fan of this type of strain relief here, because like right where it comes out of it, it's sometimes they'll fray right here. But this one, it looks pristine. So there's no visible breaks on the cable itself either. Nothing funky, nothing weird. One thing I have noticed though, this is the HP power supply, and this one's plugged in at the moment. If I put it up real close to the microphones, you can hear a high-pitched whine. Alright, so I'm hoping that comes through. When I plug in the ASUS one, you hear absolutely nothing. Although, I did notice that if I put it up to my ear, and you can't hear it on the microphone, but I can hear it if I put it up to my ear and I just, I stay super quiet, a 60 hertz hum coming from here. So this should not be technically running at 60 hertz. It should be operating at like a really high switching frequency. So it seems to me like the problem's going to be inside the actual power supply. And I figured since it's not working anyway, let's just go ahead and open it and see what we can find. I don't know how much luck we're going to have opening this up without completely destroying it in the process. It's got the seam here, but I mean, these things are usually like bonded together. This case is really sealed here, but here's something that seems to be working, and I had never actually tried this before. I took a blade, I put it in the crack here where the two halves are joined together, and then smacking it with a, well, I'm using a plier here, but you can use anything else. Okay, this time it cut all the way through, but on one of the other sides here, it only partially came apart. It didn't exactly cut it through, but that seems to be working without destroying the case too much. So I think I'm going to continue doing that all the way around. Alright, it finally came apart, and luckily for us, there are some plastic tabs here that didn't break that go to some corresponding clips on the inside of the case here, so we might be able to just easily close this back up. That's cool. Alright, so what do we have? We have our standard little compact switching power supply. Somewhat glued to the case half there. Nothing right off the bat that looks problematic. I don't know if this capacitor here has a charge or not, so I'm not touching the bottom in case you can't tell there. I'm just kind of holding it from the sides here. There is what looks like a fuse right here, but if this fuse was blown, I don't think I would be able to hear a 60 hertz hum at all. Okay, disclaimer time. Don't play with high voltage circuits if you don't know what you're doing. As I'm going to show you here, if I probe that capacitor right at its terminals, we have 136 volts still charged in there. So apparently this doesn't have a bleeder resistor. So if I were to touch that, I'd probably get a pretty good shock there. But I'm just going to leave that alone for now. What I actually want to do is plug it in and see if there's anything at the output over here on this side. Because that's where the cable comes out to go to the ferrule connector. So I'm going to plug it in and see what we're getting here, if anything at all. Like I said, the cable itself doesn't look bad, but who knows. Okay, I'm plugging this in here, but I have the other end of that extension cord unplugged, so it's not a problem if I touch this here right now. So that looks pretty safe there. It's not going to touch anything, not going to short. Plugging it into the wall now, and now I can check the output here. I'm not sure which one's positive and negative here because I can't tell, but nope, still reading 0. And let's see if that cap charged up again, or if it charged up to more than it had. Yeah, 162. So that's definitely, so that means that the rectifier at the mains should be working. But anything down from that doesn't appear, or something down the line is not working. Well, hello there. Out of the corner of my eye, I just happened to take a glimpse at the inside of this case here, and look at this right here. It's like a discolored spot where it looks like something must have popped underneath, and what's there in that spot would be that's this little section of the board right in this area. So it looks like something may have popped, although nothing obvious from what I can see. Found it. See that resistor right there that says 2R2? It's popped. Why did it pop? I have no idea. But yeah, it's kind of hard to tell here. I might have to do like a really close-up picture. Right there you can kind of see it. But yep, that's damaged, and that's like right in that area where that discolored spot is. Okay, well, I was going to try to do a repair on this power supply, and here's the resistor that I pulled from here, and I kind of started tracing it out to try to see where it went and what may have gone wrong. It leads, some of the leads kind of go over here to the traces go over to a transistor that was right here, which is this one here. And when I started checking this to see if there was any problems with it, I found that there was a short between this point here and this point here, so I thought maybe this transistor was bad, so I pulled it, but then measuring it out of circuit, there is nothing there, but there was still a short present here. And these traces lead off to go to this area where this chip is, and this is pretty much the switching controller for this whole power supply. And this has markings of 41 and then an equal sign and then E1U. And we can kind of see it there, but I'll show a closer picture of it. Unfortunately, I couldn't find any sort of like reference to any specific part numbers for this. Although just searching for some random terms on Google, like, you know, the SOT 236 DC, or not DC, but like switching controller and all that stuff, I finally came across one part number from a company called Rich Tech, which is an RT7736. And looking at their simplified applications circuits, like their simplified diagrams, this chip suspiciously matches up with, you know, kind of what they got there. Well, as far as like everything else is concerned, like all the connections, they all seem to sort of match up. So it seems like it would be something similar to that, although in their ordering list, this number doesn't appear at all. This 41, the E1U, towards the end there appears to be some sort of a date code, and then 41 corresponds to different types of the same part number. But like I said, this one doesn't match up with anything that's on that list there, so it's probably a different part number, although maybe somewhat of a similar circuit. But either way, it doesn't look like I'd be able to order this anywhere or anything, so I think we're kind of hosed on this. So sorry, man, guess gonna have to replace this power supply. And on that note, we're gonna conclude this video here. Yeah, we're not gonna be able to do anything about this power supply. So I just realized that the date and time on that thing is completely wrong. It's actually Thursday. So what's the real kicker here? Well, apparently after reinstalling Windows, coincidentally this power supply just happened to die. So there was nothing absolutely wrong with the laptop itself or the battery. So yeah, chip going bad in here caused us a lot more grief than was necessary, but there we are. At least the laptop's working, so I guess that's good. Alright guys, I'll see you guys next time. Remember, if you like this kind of stuff, to thumbs up and subscribe if it's the first time seeing this and you haven't subscribed yet. Thanks guys for watching. I'll see you guys around the bench.